Hello, everyone. This lecture series is going to be about engineering mechanics statistics. So, let me start this course by asking you a question: how this world works? What rules does it follows, and can we understand these rules and use it for our benefits? For instance, our solar system is made up of star, a sun, 8 planets, more than 210 moons, a bunch of comets, asteroids, and several dwarf planets such as Pluto. And our solar system is just an average system in a Milky Way galaxy, and there are billions and billions of galaxies in our universe. Have you ever wondered what makes all this work? How is it possible for a moon to revolve around Earth and Earth along all these planets revolve around sun and so on? Or even if you look on Earth and you see a plane flying on the skies, what makes a plane fly? How is it possible that such a massive object is able to take off from ground? Or even if you look at a tall building, how they manage to stand tall. You have strong winds, storms, but they manage to stand still. What makes them stand? What makes these machines work? They have all these components and parts moving together with each other. How they're able to lift these objects? Or even if you see a person walking, how is he able to walk on the ground? Okay, let me clue you in. He's able to walk by using principles such as friction, gravity, and many other principles of science. Now, what are these principles? What is friction? What is gravity? And how we can make sense of all of these principles? Similar principles are also followed, for example, in apple, if a falling from a tree. These principles, which we will study in this lecture series, are called principles of mechanics. Now let us go back in history. Archimedes, an ancient Greek mathematician and physicist, was born in 287 BC. He once said, "Give me a lever and a place to stand, and I will move the earth." His broad claims comes from his work on levers and his understanding on machines of systems. Studying engineering mechanics is crucial for anyone venturing in the field of engineering. Engineering mechanics is a foundation for most of the branches of engineering, including civil, mechanical, aerospace, agricultural, and others. So, studying engineering statistics and mechanics can equip you for a wide range of opportunities and careers in the field of engineering and the related areas. Let me give you some examples. For example, in mechanical engineering, we use engineering mechanic principles to design, analyze, optimize mechanical systems and components. In civil engineering, we use principles of engineering mechanics to design, analyze structures such as buildings, bridges, roads. We also use engineering mechanics in aerospace engineering for designing and analyzing aircrafts and spacecrafts. We use engineering mechanics in automotive engineering for designing and improving vehicles. Material engineering use engineering mechanics principles to understand the behavior of materials, to develop new materials, and also improve the existing ones. In robotics and automation, we use engineering mechanics principles to design and control robotic systems. We use it for analyzing data from sensors and optimizing control algorithms. We also use it in manufacturing engineering for optimizing manufacturing processes and ensuring product quality. So let us define mechanics, what is engineering mechanics, and what is engineering mechanics statistics, which is the part of our lecture series. So mechanics can be defined as branch of physics that deals with effect of forces and bodies. So basically in engineering mechanics we have two components, bodies and forces. And what we study in mechanics is what are the effect of forces on these bodies. Now, what would be engineering mechanics? Engineering mechanics is nothing but the application of mechanics to solve engineering problems. And engineering mechanics statistics would be application of mechanics when the bodies are at rest. So basically there are two types of bodies we can define in terms of motion. Bodies at rest and bodies at motion. So whenever we have motion, then we have all other kind of things such as acceleration and moment of inertia and these kind of things. So Engineering mechanics statistics is the study of effect of forces on bodies at rest, which would be our lecture series. So this course is divided into 11 chapters, and chapter 1 would be on general principles. And in this chapter, we will discuss fundamental concepts, we will discuss about units of measurements, what are the system of units, and also some general procedures for analysis. Chapter 2 would be on the first component of mechanics, that is forces. So in this chapter, we're going to study what are scalars, what are vectors, how we can use vector operations, how we can add forces, and also we'll study this dot product. Chapter 3 would be on the second part, which is object. So objects can be of many types. Particle is one of them, and we'll study equilibrium of particle object in this chapter, and which can include conditions for equilibrium of a particle. Free body diagram we'll understand coplanar force systems, and also we'll also venture into three-dimensional force systems. Chapter 4 would be on force system resultants, because usually there is not just one force acting on an object, there can be multiple forces. So this chapter will deal about that. So in this chapter, we're going to study moment of force scalar formulations, what are principle of moments. Moment is also a very important concept in mechanics, and we'll also study cross product. Chapter 5 would be on equilibrium of a rigid body. Rigid body is also one of the object. So we'll study equilibrium of a rigid body, and in this chapter, we're going to study force body diagrams, free body diagrams, conditions of rigid body equilibrium. We'll also understand equations of equilibrium and constraints and statistical determinacy. Chapter 6 would be on structural analysis. Now, whenever you have forces acting on an object, the object can also have certain forces acting on them too. So to really understand, we will try to go deeper in this chapter. So in this chapter, we'll study method of joints, method of sections, we'll study frames and machines, and also space trusses, and also zero force members. So whenever you have forces on an object, you will have internal forces as well. So in this chapter, we're going to study the impact of external forces in internal forces. So this chapter would include development of internal forces. We will study shear and moment equations and diagrams. We'll study distributed load, shear moments, and also we'll study cables. Chapter 8 would be on friction. And in this chapter, we'll study drive friction, frictional forces, rolling resistance, among other things. Chapter 9 would be on center of gravity and centroid. So these are also very important concepts in engineering mechanics. And we will study center of gravity, center of mass, and centroid of a body. There are a little bit differences between these things, which we'll study in chapter 9. And we'll also go deeper into the resultant of distributed loadings and composite bodies. Chapter 10 would be on moment of inertia. Moment of inertia is also one of the very important topics in engineering mechanics. And in this, we'll understand parallel axis theorem, what is Mohr's law, what is mass moment of inertia, or what is moment of inertia of areas in general. And last chapter would be on virtual work. And in virtual work, we'll understand principles of virtual work, what are conservative forces, what is the potential energy, and how we can determine stability of an equilibrium. So this is a course outline, and see you in the first chapter.